All right, so looking at the first one on your test, you're driving a race car, 52.0 meters per second, deploy the braking systems, begin uniform negative acceleration, come to rest 5.5 seconds later. How far did you travel? So you're looking for displacement here. The equation that you have in your little bundle of tools so far, the one that we've derived, is this. Delta x equals 1/2 vi plus vf delta t. And this is a straight application of this. Most of you did very well with this. I don't think anybody missed this. A lot of you are needing to brush up on your sig figs, and that's fine. So here, it's simply a matter of plugging in. But what I'm going to recommend, and the reason I do this, you're going to end up with 4 equations that you're going to use to solve all these kinematics problems. You'll rearrange them, you'll swap pieces in, you'll have 4 big derived equations you're going to use. So right now it's easy, you only have one equation other than the little basics that you've derived from. Before you write down an equation, so let me erase that, write down your variables. The reason for that being, as we move on to problems where you've got a number of equations to pick from, you need to pick the right equation, and the only way to do that is to know what factors you are relating. So the first thing I'm going to do in this problem, Gesundheit, is write down my variables. Okay, I know I can have a displacement. It asks for displacement, a vi, a vf, a delta t, an acceleration. Okay, which of those things do I have? Well, I'm being asked to solve for delta x. I have a VI of 52.0 meters per second. Do I have a VF? Yes, because I'm coming to rest. So VF is 0 meters per second. Do I have a time? Yes. 5.5 meters per second. Do I have an acceleration given? No. So I'm just going to do that. All right, so now I know that the 4 things that I need in an equation that relates are displacement, initial and final velocity, and time. Well, you've only got one equation, really. We've only derived one equation so far, and it just so happens that it relates those 4 things. Obviously, that's the one we're going to use.
Real quick, Miss Elizabeth.
Yeah.
Your time is in velocity.
Oh, geez, thank you. 5.5 seconds. Is that better? Okay. So now we have just a matter of plugging in. You don't even have to rearrange. This is fairly straightforward. You get a raw answer, and I'm not going to plug everything in for the sake of time. 143 meters. Based on our givens, we can have 2 sig figs. So your displacement, your correct answer is 140 meters. And like I said, most of you got that. I will take a photo of this key, and I'll put it online. So I'll also hang it in the hall for a day, but a photo on PB Works I think will do better. All right, we'll come back to number 2. Okay, so looking at number 3 on the back, you're riding a skateboard down a small hill. You have an initial speed of 4.3 meters per second. The hill causes you to accelerate uniformly at 3.00 meters per second squared. 4.5 seconds later, you're at the bottom of the hill. How fast are you going? So, again, let's write down our variables. We could potentially have a displacement. We have an initial velocity. We're looking for final velocity. We have an acceleration. We have a delta t. Okay, so leaving this one alone for now, because we're not dealing with displacement in this part of the problem. We have a given initial velocity, 4.30 meters per second. We are asked to find final velocity. We are given an acceleration of 3.00 meters per second squared, and we are given a time of 4.5 seconds. So, you want something that ties together those 4 things. That's not the derived equation that you used on problem 1. This goes back to one of your more basic equations. Acceleration is equal to VF minus VI over delta t. Okay? And that's just change in velocity. So we can, again, we do have to rearrange here. So A delta t equals VF minus VI. A delta t plus VI equals VF. So now we can plug in 3.00 meters per second squared times 4.5 seconds plus 4.30 meters per second equals V sub F. And we get a raw answer of 17.8 meters per second is your final velocity, which, by the way, is pretty speedy on a skateboard. That would terrify me. We can only have 2 sig figs, so we end up with a final velocity of 18 meters per second. Okay? Be comfortable with that. A lot more people missed this one, and number 4, a lot of people missed. So, okay, let's get rid of, we're going to get rid of all of this stuff. I'm not going to get rid of this yet, because this is actually a continuation of problem number 3 from the last problem. How long was the hill? So now we're being asked for this displacement. There are 2 main approaches to this. So one thing that you could do, and I'm going to advise you strongly not to do, is to plug in, oh, well, I have my final velocity now, it's 18 meters per second, and you can plug that number in, you can use an equation that ties those things together and get a displacement. You can use delta x equals 1/2 VI plus VF delta t. I'm going to advise you strongly not to plug in numbers that you have calculated. Reason being, number 1, there's always the temptation, which I know you're all able to resist, of plugging in the rounded number. That produces a ton of error. There is also the possibility that you have made a simple calculator error, and you've got an incorrect number that you've calculated. Well, if you're plugging in a number from a previous problem into a new problem, then suddenly you've doubled your risk of error, in essence. You've got a serious risk there. So what I'm going to advise you to do instead is a technique, it's, solve and substitute, solve and substitute, solve and substitute. So we have this equation that will relate these things. Delta x equals 1/2 VI plus VF delta t. We did calculate VF in the last problem. We could, in theory, use it. But the other thing that we have going for us is that we have this equation. Acceleration average is equal to VF minus VI over delta t. And we have acceleration, and we have time, and we have initial velocity. We can solve this. So we can solve this. Acceleration is times delta t plus VI equals VF. We now have an expression that we can plug in there. Okay? Does it lead to a few moments of messy algebra? It does. But you can handle messy algebra. In the end, you may come to love messy algebra. So let's plug that in, rearrange this equation. 1/2 VI plus quantity A delta t plus VI times delta t. Now, you can stick numbers into it right now. I would advise that you simplify that somewhat before you do that. Reason being, the more complicated the expression is, when you start plugging numbers in, the more likely you are to make a mistake in calculation. So let's go ahead and simplify that to the largest degree we can. Okay, let's multiply everything by delta t. So we have 1/2 delta t, well, VI delta t plus A delta t squared plus VI delta t. Okay, this is good. Oops. And actually, we don't need that bracket anymore. So then let's continue to simplify. Delta x equals 1/2. Well, we've got VI delta t and VI plus VI delta t. That's 2 VI delta t plus A delta t squared. Can we simplify this further? We can. So delta x equals, multiply that 1/2 across, VI delta t plus 1/2 A delta t squared. You now have an expression that you can plug straight into. You should come up with a delta x. Your raw answer is 49.725 meters. 2 sig figs gives you 5.0 times 10 to the first meters. Okay, go to break.